Let's learn in this video the different options to access the AKS control plane. So we'll be exploring the public cluster, private cluster, and the VNET integration feature. When we talk about accessing the AKS cluster, we have actually three types of access. So first of all, we would have the user who wants to access the exposed services inside the cluster. So that user will use like public IP address, public load balancer, or an ingress controller, and you will be able then to access and reach the pods or the services exposed inside the worker nodes. This scenario will not be talking about this scenario for this video. We'll dismiss it because that's totally another topic. What we'll be talking about instead is the access to the control plane itself. Okay, so for that we have two scenarios for accessing. So we have first the developer, the DevOps team, the ops, and the DevOps pipelines that wants to access the AKS control plane to deploy and configure applications. So that's this entity right here. And then the other ones who wants to access the control plane are the worker nodes. Those are our node pools who wants to access the control plane or the API server in order to get the cluster configuration and to be able for a control plane to be able to deploy pods inside those worker nodes. So AKS, when it was first introduced 4 or 5 years ago, it did supported only the public cluster. Public cluster means that a control plane have a public endpoint that have a public FQDN and a public IP address. Then, few years later, AKS introduced the private cluster so that the control plane will be accessible only through a private endpoint, so that a control plane would have only a private IP. And now, few months ago, AKS introduced the VNET integration feature that could be used with a public or private cluster. We'll explore all of these four features in this demo, and we'll see what are the architectural changes for each mode. So let's start first with the very basic, very simple, that is the public AKS cluster. What makes it public cluster? What makes it public actually is the access to the control plane. It will be done through a public endpoint that is a public FQDN and the public IP address available and exposed over the internet. So the users, they can use the kube control in order to access that control plane, deploy applications, and so on. And also the worker nodes will be accessing that control plane through a public IP, so that traffic will go through the internet. And the issue here for some organizations that require very restrictive security rules and so on is that they have a public endpoint exposed over the internet that might be attacked and so on. So for this case, a public cluster have some tools to secure it, like using the authorized IP ranges, where you can whitelist the IPs that can access to the control plane. So any other IPs will be denied by the firewall. But still, for some organizations, this is not enough. So for that, they will leverage the private cluster. We'll explore that option later. But for now, let's see for a public cluster what are the exposed endpoints. So from here, I have already created the resource group, created an AKS cluster, and then I show here an attribute from the JSON for my AKS is the FQDN. So this will show me the public endpoint or the public FQDN for the public cluster. And as you see it here, it is the name of my cluster, then with an ID, .http, the resource location or the region where I have deployed my cluster, .azm kubernetes.io. Now, if I try to resolve the IP address behind that public FQDN using NSLOOKUP, for example, I will see here the address is a public IP address. So for that, we say it's a public cluster. And a Kubernetes cluster would have actually two attributes, FQDN for public FQDN and private FQDN. For a public cluster, we don't have a private FQDN because it's public, so it does make sense. Now, how the worker nodes connect to the control plane in the public AKS. We have already answered this question. Those worker nodes will go through the public IP address. It means it will travel through the internet. Let's do a demonstration on that. So here I have in this commands. What I do here is that I connect to my cluster, I get the services, call it Kubernetes. That's a typical Kubernetes service that you will find always installed by default on your AKS cluster. Okay, it points already to this IP address, and if I try to resolve or to describe that service, I will see here in endpoints I have a public IP address for that service. Okay, by the way, this is the service that will be used by the worker nodes and by the pods that wants to connect to the control plane. They will use this service to resolve the IP address for the control plane, and in this case it's a public IP address. In a public cluster, we would have this infrastructure created right here. So it's a regular infrastructure where you would have a virtual machine scale set, the managed identity to connect to ACR, the virtual network, the load balancer, public IP address, and network security group, and a route table if you are using the KubeNet mode. Now let's make our cluster more secure. So after introducing the public cluster, AKS introduces the private cluster. What that mean? So private, again, it's a description for the access to the control plane. So it means here that the control plane is exposed on public FQDN, but only with a private IP address. So the control plane endpoint is not exposed to the internet itself. It's just the public FQDN that is exposed to the internet. And even that public FQDN, it could be disabled or enabled again. Okay. The worker nodes then will connect to the control plane through the private endpoint. So now that we don't have yet that public IP, the control plane would be injected into or projected into the AKS VNet through using the private endpoint. That private endpoint will route traffic to the control plane. So for my worker nodes to connect to that private AKS, they will not use the public traffic through the internet, but they will go through private traffic through the private endpoint. And the same for these DevOps teams and the kube control command line. If they want to access to that private cluster, actually they will not be able to access on the public endpoint, because we don't have a public endpoint right now. It's a private IP address, and then the only way to connect is through a Jumpbox virtual machine that is deployed inside the AKS VNet or period network. And because this private endpoint is using private IP address, and that might change actually, for example, if we restart the cluster or for any reason it might change, for that we use the private DNS zone that will be leveraged by the private cluster, and you can use it in order to resolve the access to that cluster. So the FQDN, the private link or the private FQDN will resolve to the private IP address that will give access to the control plane. So now we have more secure traffic that goes through the private endpoint. Let's now see a demo on slides. I will not be coding this because it takes actually lots of time to run this code during recording this session. So I prefer to do it statically using print screens. So here I create a private AKS cluster. So I create a resource group, create the private cluster using the flag -- enable private cluster, and then I show the public FQDN for my private cluster, and yes, it does have a public FQDN, and they can resolve that public FQDN using a tool like NSLOOKUP. And if I do that, I'll get a private IP address. So there is no public IP address right there. And now if I try to query the private FQDN, I will get the private FQDN. Note here how it's using private link. But if I try to resolve that private FQDN, then tells me here non-existent, because it's resolvable only from within the network where I have the private DNS zone defined. Okay, and that's only within the AKS VNet. Great, so this is a fully private cluster. Just one issue here is that it have a public FQDN. So as we said earlier, we can go to disable that public FQDN using the AKS update, then dash dash disable public FQDN. And when we do that, we run that command. Don't worry about the dash C because I have disabled that. So here, if I disable it, I query again the FQDN, I will not see anything. Okay, it's gone. It was disabled by AKS. So the only way to access this cluster is through the private endpoint and to be through a machine in my VNet. A private cluster, when it's created, it will go to add a private endpoint and the private DNS zone. So if you take a look here at the managed cluster resource group within AKS private cluster, we would see here the typical components for a Kubernetes cluster, and also you would see the three components that were created automatically for me, which are the network interface that would host the private IP address from the AKS VNet, and also we would have the private endpoint that will route traffic to the API server, and note here its name is cube-API server. And in order to resolve that private IP address, will Kubernetes or AKS will go to create also a private DNS zone with the FQDN, with the private FQDN for the control plane. Note here how it's using also the private link FQDN. If we take a look at this private DNS zone using on the Azure portal, you will see here the records that were already created. So this is the name of the private DNS zone, and here we have a record that points to the private IP address of the control plane, which is 10.224.0.4, which is an IP address from my VNet. Okay, so that's actually the IP address of the private endpoint that will lead the traffic into the private cluster. So a private cluster will make the only way to access the control plane is through the private endpoint. Okay, but now we have another feature which is creating like a private or public cluster using another feature that is VNET integration. So what is that? So with VNET integration, it will act actually differently for how the node pools will access the control plane and how the DevOps or the kube control will access the control plane. One would be publicly, so for the kube control, and for the CD pipelines, they can access publicly to that control plane. The control plane actually is exposed on a public FQDN with a public IP address. Okay, but now what interests most the users or the operators is that to secure this traffic from here, from the node pool into the control plane, and they want it to be inside the same network or to be network optimized. So when we enable that VNet integration, AKS will go to inject or it will go to inject an internal load balancer into the delegated subnet. Okay, so that way the worker nodes will be able to access privately to the control plane through a private IP address that is the private IP of the internal load balancer. So this will create another subnet into the AKS VNet. So this means here that our control plane now has two endpoints, one public endpoint for the kube controller for the CD pipelines, and that public endpoint could be disabled if you want to, but it does have also a private endpoint for connecting the worker nodes privately to the control plane. How VNet integration works. So to understand that, let's create here a Kubernetes cluster that have the feature enable API server VNet integration already enabled. Okay, then let's go to query the FQDN of that cluster. So we'll find here a public FQDN, and behind that public FQDN, you will find here a public IP address. Okay, and here if I try to get the private FQDN, hey, we don't have any private FQDN defined here. So the private FQDN doesn't exist in itself, but the private IP address to access the server or the control plane, it does exist. Let's see that in this demo right here on this script. So now how these worker nodes will be able to access the control plane. So as we said, the control plane does have a public IP, they can use it, okay? But here the interest of using the VNet integration is that those worker nodes will use the private IP, IP to access that control plane. So let's see how that works. So here I get the credentials to connect to my cluster, I get the services, and again I focus on this Kubernetes service because that's the service that gives me access to the control plane for the AKS cluster. Here if I describe that service, note here the endpoint is leading me to the private IP address for the control plane. So actually this is not the private IP address for the control plane itself because it's hosted on a Microsoft managed subscription and Microsoft managed VNet, okay? But this is the IP address of the, let's discover that in the next slide. So take note of that IP address 10.226.0.4. Next here, I go to view the resources created by that VNet integration enabled public cluster. So here, the only thing that it will add is this kube API server. Not the only thing, it will actually deploy second one, and that's a private load balancer. So, and that private load balancer does have here a private IP address, which is the same IP address we have seen in the Kubernetes service. 10.226.4. And because this feature is using VNet integration, so it will use delegated subnet. So here, if I go to the AKS VNet, we'll see here it does created a second VNet called AKS, or second subnet called AKS-API server-subnet with /28, and that's a delegated subnet delegated to the managed clusters, which is my AKS cluster. And then this internal load balancer will be injected into this delegated subnet so that worker nodes and control plane can talk to each other using a private network. So this is public cluster using VNet integration. Let's see now how to work with private cluster that uses VNet integration. So with this mode, the thing that will change is that the control plane will have only a private IP address exposed on an internal load balancer that is injected into the AKS VNet through a delegated subnet. So this public access that was possible through the VNet integration with public cluster now is no more available. So we don't have here a public IP that exposes the control plane. This control plane still have a public FQDN exposed to the internet, but that actually references a private IP. And because this is a private cluster, so that public FQDN could be disabled. And now if I have my CD pipelines or the operators who wants to access the control plane, then because they don't have a public endpoint available, they will use actually the internal load balancer. They will pass through the VNet, the AKS VNet. So I should have a jump box deployed into the AKS VNet so that they can get access to that control plane. So this is a private cluster, but we don't see a private endpoint. Actually, that private endpoint will be replaced by this internal load balancer through the delegated subnet that will enable communication over secure channel between the AKS control plane and the worker nodes. And note how we have here a DNS, private DNS zone to resolve the private IP address for that internal IP. Now, to create this kind of cluster with this access mode, here we have created a resource group, created a new AKS cluster using the two flags, enable API server VNet integration, and then enabling private Kubernetes private cluster. Okay. I can then query the FQDN, and from here I will get the public FQDN for my cluster, try resolve it, and here I get a private IP address because it's a private cluster. Try then to get or to query the private FQDN. We have a private FQDN, but with a private link, but actually that doesn't point to a specific IP address because it's resolvable only from within a machine inside the AKS VNet, and I was running those commands from my own developer machine outside of the AKS VNet. A private cluster with VNet integration will add two components, internal load balancer and private DNS zone. So we can view these components added from here, where we have the internal load balancer and the private DNS zone that will give me access to the control to the IP address for the control plane. So if we take a look at that private DNS zone, we will find here the A record for the private IP address for the control plane, or actually for the internal IP for the internal load balancer that will route the traffic to the control plane. So now if I want to access my cluster that is a public cluster, then there is no issue because we have a public FQDN with the public IP address. But if I have a private cluster, either with private cluster mode or with API server integration, then I would use here the those four options I have. So first and easiest option is to use kube control command invoke. So here you type commands like kube control get pods. Okay, so this would be an example of a command: kube control command invoke dash command, and then you type the command you want to run. So this will go through the control plane of AKS in Azure. Okay, so Azure will figure out how to run this command inside your cluster. And then of course this is not what you want to do in production, so this is just for debugging and so on, troubleshooting. Then if you want your CD pipelines to be able to deploy, or if you want to get access as an operator, then you would typically choose a Jumpbox virtual machine inside the AKS VNet or a peered network so that you can get access either to that private endpoint or to the internal load balancer. Another option could be using the express route or VPN connection into the VNet, or using a private endpoint connection, as we have seen with the private cluster mode. So we have four options to create the Kubernetes cluster for the control plane. Let's do a recap here. So first we have the public cluster. It does have a public FQDN with a public IP. It doesn't have a private FQDN, and it does have a public FQDN that could be deactivated. It could not be deactivated actually, and then to access that control plane is easy because you have public FQDN and a public IP accessible over the internet. For a private cluster, things are different. So you have a public FQDN that points to a private IP, and you have a private FQDN that points you to the private endpoint, and that is resolvable only from your VNet. For that, you have a private DNS zone that will help you to achieve that, and it does not does have a public FQDN that could be deactivated. For VNet integration, we have two modes: VNet integration with public cluster and with private cluster. With public cluster, yes, you would have public FQDN that resolves to a public IP, and you do have a private FQDN with a private IP for the internal load balancer, because in VNet integration, an internal load balancer will be created for you. And because here it's not a private cluster, so you could not deactivate that public FQDN. You can do that only for private clusters. So now with VNet integration with private cluster, you would have a public FQDN that points to the private IP, and then it would have a private FQDN resolvable over the private endpoint and private DNS zone, and the public FQDN, it could be disabled. Okay, so in a nutshell, that we're going to create the VNet integration using that delegated subnet, and then the internal load balancer and the private IP, private DNS zone. Great. So here I'll give you more resources if you want to take a look and learn more about this topic. And of course, I would also give you, so you should also take a look at this workshop that I have created in this public GitHub repository, Docker Kubernetes course, the chapter number 24, where you go to explore the private cluster. So all the commands that I have used in this workshop are available here, along with the schema that I have used and so on. So I hope it will be helpful for you. Thank you.